I'm not talking about your neighbors, I'm talking about aliens. And not just any aliens, I mean advanced civilizations, beings who have figured out how to build spaceships, radio telescopes, maybe even more technology than we can imagine. The thing that troubles me is that with all those stars out there, with all those planets, we should be drowning in signals. But we're not hearing anything. And today I want to talk to you about why. But here's the twist, and this is what really gets me. I think the answer might not be that aliens don't exist at all. I think maybe, just maybe, we missed them. We got to the party a billion years late. Let me start by doing what I always like to do, taking something that seems complicated and breaking it down into pieces we can actually think about. Because that's the only way to understand anything. You have to understand it piece by piece. So let's talk about how many intelligent civilizations there should be. And yes, there's actually an equation for this. A physicist named Frank Drake came up with it back in 1961, and it's one of the most famous equations in science, second only to Einstein's E equals mc squared. Now, the beautiful thing about this equation is not that it gives us an answer, because frankly, we don't know most of the numbers. But what it does is it forces us to think clearly about what we need to know. It organizes our ignorance, as one scientist put it, and I like that phrase. Here's the idea. The number of intelligent civilizations we can detect in our galaxy depends on several things. First, how many stars form every year? Well, we're pretty good at counting that now. About 1 to 3 sun-like stars form in the Milky Way every year. Then what fraction of those stars have planets? Well, we used to think planets were rare. We didn't know of a single exoplanet until 1995, but now we know almost every star has planets. Could be 1, could be 10. And some of those planets sit in just the right zone, not too hot, not too cold, where life could exist. We call this the habitable zone, the Goldilocks zone, just right. Now the interesting part, the part where things get fuzzy, is on how many of those habitable planets does life actually appear? And then of those, on how many does intelligence emerge? And of those intelligent beings, how many actually develop technology? How many build radios and telescopes? Well, look at us. We're here. We did it. So the probability is greater than 0. That part we know for sure. But there's one number in that equation that absolutely drives me crazy. And that's the last one. That's the lifetime of a civilization. How long do advanced civilizations last before they disappear? And here's why I'm so troubled by this. We have only one example, us. And we've only been broadcasting radio signals for less than 100 years. 100 years! Out of how many millions or billions of years that life has existed on Earth? It's like watching someone live for 3 seconds and asking, how long do humans live? You just don't have enough information. So when you multiply all these probabilities together, you get a range of answers. Some scientists say there should be thousands of civilizations in our galaxy. Some say maybe millions. Frank Drake himself, when I last heard, thought there might be around 10,000. But other scientists look at the exact same equation and come out with an answer of maybe 1, just us, alone in the whole galaxy. The answer depends entirely on what assumptions you make about those unknowns. Now here's where it gets interesting. In 1950, a physicist named Enrico Fermi, brilliant man, Nobel Prize winner, sat down for lunch with some colleagues, and he started thinking about this same problem. And he got so depressed that Enrico Fermi, this giant of physics, became sad. Actually sad, because he realized something that doesn't quite add up. He said, the aliens, where are the visitors from advanced technological civilizations? Because think about it. We have about 200 billion to 400 billion stars just in our own galaxy. Many of them are older than the sun, billions of years older. Some of those older planets must have had intelligent life. Some of those must have developed technology. Some of those must have figured out how to travel between stars. And if they got that far, they could have spread throughout the entire galaxy. With just relatively slow spaceships, nothing fancy, just slow chemical rockets going at a fraction of the speed of light, they could have colonized the entire galaxy in just a few million years. That's nothing. That's a blink of an eye in cosmic time. The galaxy is 13 billion years old. So why don't we see them? Why doesn't our sky look like Grand Central Station at rush hour? Why don't we pick up their radio signals? Why hasn't anyone landed on our planet? This is the Fermi paradox, and it is genuinely unsettling. So what's going on? Well, there are several possible answers, and I want to explore them with you because they're all interesting, and they all teach us something important. The first answer is the simplest. Maybe we really are alone. Maybe the probability of intelligence arising is so incredibly small that Earth is the only place it's happened in our observable universe. Now this sounds depressing, but you know what? Feynman actually found this to be oddly comforting. He pointed out something brilliant. He said that we got incredibly lucky. He called it the anthropic principle. We're here, so obviously it happened at least once. But maybe the circumstances that led to us were so extraordinary that they could never happen again in a trillion universes. And if that's true, then maybe we don't need to worry about other civilizations beating us to it. Maybe we're truly unique. But here's the problem with that answer. Even if we're extremely rare, the numbers don't quite work out. There are 10 to the 22nd power, that's a 1, followed by 22 zeros, stars in the observable universe. Even if intelligent life is vanishingly rare, even if the odds are 1 in 10 billion trillion, those numbers are so big that intelligent life should still exist somewhere. The math just doesn't let us be alone. So that brings us to another answer. And this is the one that keeps physicists awake at night. It's called the Great Filter. The Great Filter is an idea that really disturbs people, but I think it's worth taking seriously because it's logical. Here's the thinking. There are certain steps that life has to take to go from non-living chemicals to a spacefaring civilization. Some of these steps might be incredibly difficult, almost impossibly difficult, so difficult that very few, maybe almost no, civilizations actually make it through. Let me list some of these steps for you. Life has to arise from non-living chemistry, that's step 1. Then single cells have to emerge. That's actually pretty straightforward. But then something remarkable has to happen. Those single cells have to learn to work together. They have to form complex cells with nuclei inside them. They have to become multicellular organisms. Fish crawl out of the ocean, dinosaurs evolve, mammals evolve, primates evolve, and then finally one species, just one, learns to use tools and develop language and build technology. We call that step intelligence. And then that intelligent species has to avoid destroying itself long enough to leave its home planet and spread to the stars. Now, all of these steps are huge. Each one is a massive leap. And maybe one of them is so difficult that almost no civilization that starts from basic chemistry will ever make it through. That would be the Great Filter. And here's where it gets scary. That filter could be in our past, or it could be in our future. If the Great Filter is in our past, if it's one of the steps we've already crossed, then it means we're incredibly rare. We're one of the only civilizations that made it this far. And that's actually good news because it means we're probably not about to hit another one. We've already climbed the mountain. But if the Great Filter is in our future, well, that's terrifying. That means advanced civilizations like ours almost always destroy themselves. Maybe they always wage nuclear wars. Maybe they always create artificial intelligence that turns against them. Maybe they always poison their own planet with pollution. Maybe they wreck their climate so badly they can't recover. Maybe the moment a species becomes technologically advanced enough to spread to the stars, something about technology itself is self-destructive, some kind of inevitable self-annihilation. If that's the case, then we're in trouble because we're approaching that level of technology right now. Now, there's something else I want to talk about because it just occurred to me and I think it's important, and it's about timing. It's about time itself. You see, all of this discussion assumes that civilizations exist at the same time. We imagine them spread out across the galaxy, all of them advanced and communicating, all of them existing simultaneously. But that's probably not how it works. That's probably not how it works at all. The galaxy is old, 13 billion years old, but that doesn't mean life has been everywhere the whole time. Life took a very long time to evolve on Earth. We think simple cells arose maybe 4 billion years ago. But complex life, multicellular organisms, those didn't show up until only about 600 million years ago. And intelligent beings, we've only been here for a couple 100,000 years. We've only been technological for a few thousand years. We've only been sending radio signals for a century. Now imagine this. Imagine that somewhere in the galaxy, on a planet orbiting a star that's older than our sun, life began earlier than it did on Earth, and it evolved faster, or even at the same rate, but just started earlier. So intelligent beings emerged millions of years ago. They built their civilizations. They became spacefaring. Maybe they spread throughout their region of the galaxy. Maybe they were wonderful, peaceful beings who found ways to live for billions of years. But here's the thing, we don't overlap. We miss each other entirely. Think of it like this. Imagine a party that lasts 1 billion years, but nobody stays for more than 1,000 years. You could have 1,000 civilizations at this party over 1 billion years, but you'd never meet any of them. You'd come to the party, you'd be there for your 1,000 years, and everyone you met would be already gone. And when you left, everyone you met would have been gone for thousands of years, and the new beings coming to the party would have never heard of you. That's what I think might be happening in the galaxy. That's what I think means we missed the aliens by 1 billion years. Not that they don't exist, but that they existed. Past tense. They came and went. They had their moment in the sun, literally the sun of their star system, and then they disappeared. And the next civilization showed up 1 million years later, and they disappeared. And another one shows up, and we're just one of thousands or millions of these civilizations, each having our moment on the cosmic stage. But here's what really troubles me about this idea. We don't know if the timeline works out that way. We don't know how long civilizations last, and until we do, we're just guessing. Let me tell you something that fascinated me when I learned about it. There was a study done by scientists at NASA and Caltech that looked at where in the galaxy life would be most likely to arise. And they found something interesting. The densest concentration of stars in our galaxy exists about 13,000 light years from the galactic center. That's where you'd expect the most life to develop. But Earth is about 25,000 light years from the galactic center. We're in the suburbs. We're in a backwater. And they also calculated the optimal time frame for civilizations to appear. They said the most likely time for civilizations to develop was about 8 billion years after the galaxy formed. Our galaxy formed about 13 billion years ago, so that means civilizations should have been popping up everywhere 8 billion years ago. 8 billion years. We've only been here for 13.5 billion years after the galaxy formed. We're incredibly young. We showed up at the tail end of the party. So there's an interesting possibility here. Maybe the galaxy was teeming with life billions of years ago. Maybe it still is. Maybe right now, far away from us, there are civilizations going about their business. But we're separated by such enormous distances and such enormous stretches of time that we never meet. We never communicate. They go extinct, or they leave, or they transcend into something we don't recognize. And millions of years later, new civilizations arise and have the same experience. This is what science calls the cosmic shuffle. Civilizations passing each other in the night. Now, I want to talk about what might cause a civilization to end, because this is important, and it brings us back to that great filter idea. When you look at the history of human civilizations on Earth, you find something interesting. Civilizations rise, they become sophisticated, they develop technology, and then they fall. Sometimes they fall because of external causes, invasion, plague, climate change. But often they fall because of internal causes. They use up their resources, they poison their environment, they wage war, they become unstable. Now imagine that pattern on a galactic scale. Imagine that this is just what happens. When a species becomes intelligent enough to develop technology, that same technology gives them the power to destroy themselves. Nuclear weapons, biological weapons, artificial intelligence that turns against them, climate-altering machines. And maybe, just maybe, every single civilization that reaches that point of technological development faces the same crisis, and most of them don't make it through. Some scientists have calculated that the average lifetime of a civilization might be only 1,000 years. 1,000 years out of billions. That's a blink. That's nothing. If civilizations last only 1,000 years on average, and if they arise sporadically over the galaxy's history, then the odds of any two of them existing at the same time and close enough to communicate are vanishingly small. You could have millions of civilizations throughout cosmic history, but they'd almost never meet. There's another angle to this that I find fascinating. It's about what's called the rare Earth hypothesis. The idea is that while planets might be common, habitable planets might be common, planets with life might be somewhat common, planets with intelligent life might be rarer, and planets with intelligent technological life might be very rare indeed, because each step requires not just chemistry and physics, but luck, a lot of luck. Earth got lucky. We got lucky with the moon, which stabilizes our climate. We got lucky that we didn't get hit by a giant asteroid at the wrong time. We got lucky that multicellular life evolved. We got lucky that mammals survived the extinction of the dinosaurs. We got lucky that primates evolved intelligence. And we got lucky that our intelligence was of exactly the right type to understand physics and build technology. If any one of these things had gone differently, you wouldn't be here watching this video. You wouldn't exist. The universe wouldn't have produced us at all. Now multiply that luck by everything that has to happen for a civilization to survive for billions of years without destroying itself. It's almost impossible. So here's what I think is happening. I think intelligent life has probably emerged multiple times in our galaxy, maybe many times, maybe most of the time. When you have a habitable planet for long enough, something eventually develops intelligence. But that intelligence doesn't last. The civilizations that develop don't survive. They hit a great filter, they destroy themselves, or they transcend into something we wouldn't recognize as a civilization anymore. And this means that right now, as I'm speaking to you, the civilizations that existed 10 million years ago are gone. They're extinct. They left no trace. The galaxies is not full of their ruins or their artifacts or their vast alien cities, because civilizations are young, they're ephemeral, they're like mayflies on a cosmic scale. We might be living in a galaxy full of dead civilizations, ghost worlds where advanced beings once walked, but now there's nothing, silence, just the slow decay of stars and the expansion of space. Now, what does this mean for us? What should we do with this knowledge? Well, first, I think it should humble us. We like to think we're special. We like to think we're the smartest beings in the universe. But we might be one of millions of species that have reached this point and faced the same crisis. And we might be about to make the same mistakes. Second, I think it should motivate us. If civilizations don't last very long, that means every civilization that succeeds, that actually makes it through that critical period and survives long term, is achieving something almost impossible. It's doing something that millions of other civilizations failed to do. That's worth something. That's worth fighting for. And third, I think it should make us think about what exactly is the great filter for us. Is it behind us? Have we already passed through the crisis point? Is it ahead of us? Are we about to face the same challenges that destroyed every other civilization that came before us? Are we at the edge of a cliff? Because here's the thing, if the great filter is real, and if it's ahead of us, then we're in genuine danger. And not just from external causes, from ourselves, from our own technology, from our own choices. You know, when I think about this, I think about that scientist, that genius physicist, Enrico Fermi, and I think about how he asked, "Where is everybody?" and how troubled he was by the silence. He was troubled by it because the math didn't make sense. But I wonder if he would have been less troubled if he'd thought about this timing problem. If he'd realized that the silence might not mean there's nobody out there. It might just mean we're all alone, all by ourselves in our own tiny slice of time. And maybe that's actually a kind of mercy, because it means that what we do matters. The choices we make in the next few hundred years, whether we destroy ourselves or learn to survive sustainably, whether we poison our planet or heal it, whether we develop artificial intelligence responsibly or recklessly, those choices matter enormously, because we might be the rare ones. We might be the civilization that makes it through, that survives the great filter. That becomes spacefaring. That spreads to the stars. Or we might fail. We might join all those other civilizations in the silence, but at least we have a choice, and that choice is ours alone.